Hi, I think we did enough data cleaning and preparation for this analysis practice. Let's jump right into fitting our multiple linear regression. And this is often what I do in my daily work. When I get a new kind of data that I don't know, I try to clean it and I try to fit regression models to understand what's going on in the data. And I believe that this kind of thinking will open your way towards more advanced models using machine learning algorithms. But first things first, let's go ahead and in this video fit our multiple linear regression and try to interpret our coefficient estimates, try to understand what these coefficients are telling us. Okay, let's start. We already created this df number 3 in the previous video. This is going to be our data set, and we can start defining our right-hand side variables in the equation. These are going to be our predictors, right? And this time it's going to be distance and rating and 3.5 star and finally 4 star. We are going to have them on our right hand side of the equation, and 3.5 star and the 4 star are the dummy variables or binary variables. When they are 0, it means the model will predict for 3-star hotels. Okay, but we will see it in a moment. First things first, let's create our model object. As left-hand side variable, again, we are going to choose price. Later, I'm going to touch also this distribution of price topic, because in some projects you may find it interesting and more useful to fit a model to the logarithm of the target price, actually. What it means is that if you remember in the first video or in the second video, we checked the distribution of price and it was skewed to the right, just like many other phenomena in the life. We see that quite often. Things are skewed, like salaries, GDP, etc. And when you take the logarithm of this variable, it approaches closer to a normal distribution, like that bell shape. And when it is a normal distribution, there are some certain statistical properties that you can use. In a study like that, you can fit that model to predict the logarithm of the price instead of the price itself. And in that case, the interpretations will change. And perhaps we will have a video about that. Just think about that. It is a thing, actually, to predict the logarithm, to fit a model for the logarithm of the target variable. Okay. However, here, yeah, we just use it as it is. It's our ordinary price in US dollars or in euro. I don't know. Okay. Let's create our model object. The model is equal to, we are going to use stats models. Later in the next videos, we will use scikit-learn. Currently, we stick to stats models, okay? And we know this OLS object, standing for ordinary least squared. And left-hand side variable is y, and the right-hand side variables are x. And we call the fit method on top of that. Let's run this and hopefully see maybe error message. Yeah, we get this missing data error. Actually, I just realized it before running the cell, but I didn't want to stop. So it says missing data error. This means basically your predictor, one of your predictors, is having missing values. That is quite straightforward to see actually from this describe output, because this rating has 307 values instead of 340. And let's fix that, because we shouldn't have missing values there. It means you should be more careful when you are cleaning and preparing your data, right? We forgot in the previous video imputing these missing values. And when you impute values, you need to have a strategy and think about it. How do you want to change those missing values? Do you want to replace them with the average, with the median, or changing grouped averages depending on something? So you can create your own strategy. For the time being, I just want to use the average to impute these missing values. So this is our rating. It looks like this. And this is a Pandas series, and it contains missing values. However, I want to fill the not available values. I can pass whatever number I want here. If I write 15 here, it will replace the missing values with 15, but I don't want just an ordinary number. I want the average of this rating. Rating, please. Okay, rating. And to compute its average, I'm going to use numpy mean. I will pass this here. This small function here computes the average of this column. Okay, and if you run this, again, it shows you the array or the series. Yeah. However, this time it is the missing values are filled with the average. And if we run this again, we will see, of course, the missing data error again, because we didn't assign this to anywhere. It is just hanging in the air. Okay, you just need to reassign your rating column. So give me all the rows, but only the rating column, and it should be equal to this expression here. When you run this, now you have your new rating column imputed. Okay, and let's now run this again. And this time, of course, we didn't get an error message because we imputed. What is next? Let's not jump into predictions first. The reason we are using stats model library is to get this beautiful summary. I have the feeling that this stats models library was built by statisticians. This is actually quite good. This is a model way better than I expected. That is quite interesting. Anyway, deeper into it, and if we find its mistake, we will make correction. Okay, so increased R squared means this model has better explanatory power. It is doing a better job explaining the target variable. Okay, and oh yeah, I think I find the missing piece here. We don't have intercept. We want a model with intercept. Okay, that was the tricky part. Okay, so we want a model with intercept, and we have this add constant, if you remember. When we add this line, we are going to have our model with a constant, meaning intercept. So yeah, now I feel much better because this is something that I would expect. The previous model that was simple linear regression, it had an R square of around 4%, and this one has an R squared of 12.5%. It means a better model for the same data. And remember, R squared was the explained variation by your model, right? And these are our coefficient estimates, and our p-values are quite okay, quite good. Generally speaking, if these p-values are smaller than 5%, I consider them as statistically significant. That 5% threshold is not a rule written to the stone. In another project, in another analysis environment, let's say for another analyst, it can be 1% also. For me, these are statistically significant in this project, okay? And these ranges, these last two columns are showing the confidence intervals for the coefficient estimates. They look also good. None of them has 0 in their range. This changes from 13 to 106 and 0 is not there. I don't want 0 to be a part of these ranges, because in that case the coefficient might as well be 0, okay? That's the trick. That's the tricky part. You don't want 0 to be a part of these ranges. And 95% confidence interval. Okay, these are 95% confidence intervals, look good. We are going to talk about the coefficient estimates and how we should read them. First, let's write our equation. I want to write what this equation looks like and how the predictions are happening actually. So the price will be equal, based on this model, the price will be equal to first 60 as your intercept minus 4.6 times distance plus 12.9 rating times rating, and then 37.1, let's say, times star 3.5, and finally 21.4 times star 4. So this is the kind of prediction equation. This equation gives you the expected price. And let's convert this cell actually to a markdown. I want this to be a text. And there is a nice trick here. You can also include Python syntax to your text, like this. Yeah, looks much better. Let's make a prediction by hand here to see how these predictions are coming into picture. So let's take a sample. So this is a hotel. It is 3.5 star. It is not a 4 star. Its rating is 3.97, and it has a distance of 2 kilometers or miles to the city center. What is the expected price based on the model? So we know the real price, it is 116, but what does the model say? So distance is 2, rating is 397, 3.5 is 1. Remember, this takes 1 or 0, dummy variable or binary variable, and star 4 is 0. Oops, I have a syntax error here. Let's correct that. It says email, perhaps you forgot a comma. Yeah, maybe I forgot a comma. That's true. .6 the distance, okay, 12 and 3.97, because this 12.9 is my coefficient. It's here. We forgot the plus sign here. Cool. This is my expected price based on this model, and the real price is 116. So what is the residual? The residual is 139 minus 116. Cool. Of course, we don't produce our prediction outputs like this, we just have a convenient function called predict, and we can call it using our model object like this, and you pass your X array or X frame. These are the X holds only those right hand side variables here. Okay, and based on these X parameters, what are my predictions? These are the predictions. And just like I have a column for the output of simple linear regression, I want another one. I want another column called prediction output for multiple linear regression for each row, but calling the column name pred multi or multi, and I will assign these prediction outputs to this column. In that, oops, I assigned it to a wrong data frame. I need to use df3. Yeah, that's the one we are using. And then if we check the head of df3, we will see that now we have both output. We have output for both simple linear regression and multiple linear regression. An interesting thing to look would be also the RMSE. So when we created a better model, how the RMSE changed, right? We can directly copy our RMSE code from the previous exercise. So here it is. Remember, RMSE is our quality metric for predictions, and smaller the better. This time I'm gonna call it RMSE multi, perhaps. And I am using the df number 3, price is still price, and pred multi is the new predictions, and I want the RMSE output, not mean squared. 52. This is again an improvement. The last time in simple linear regression, if I remember right, the RMSE was around 90 or 85. This is an improvement. On top of that, it gets smaller. As you include better predictors and better models, this RMSE will decrease because of the reasons we discussed in the previous lecture or in the previous video. Okay, a little more about the interpretation of these coefficients. It can be important. So when you are doing the interpretation of the coefficients, you need to always remember that they are for this data only. For another sample, another data, they can be very different. And your estimates are on average for this data in our hand. We don't know the external validity, and we cannot know anything about any other city other than Vienna. But later we will touch also on those topics. Okay, you can say that average price for records, if all the variables are 0, are the constant, because that's how we write the equation. If rating is 0, stars are 0 here, and distance is never 0, right? We will end up with the intercept and some distance value. In that case, we are looking at the 3-star hotels. So 3-star we will be comparing different 3-star hotels with changing values of distance in that case. And the rating, let's try to interpret rating lastly. So those hotels will be $12 or $13 more expensive, keeping all the other variables unchanged by 1 unit change in rating. So if you increase the rating by 1 unit from 3 to 4, let's say, you expect 12.8 euro or dollar more price on average in this data. Okay, that's how you should be carefully interpreting these coefficients. And the more you think about the interpretation of these coefficients, I think the better you will get with understanding the data the business teams throw at you. You will be working in different projects, you will be getting new data from different people, and if you include these things into your meditation, let's say, chances are you will learn more and you will ask better questions, in my opinion, to both data engineers and to the business teams. Okay, in this video we quickly fitted our multiple linear regression and talked about its interpretation. And before finishing, let's quickly check that scatter plot, right? How the scatter plot looks like this time. I want to create a scatter plot. On the x-axis I want to have my real price, and on the y-axis I want to have my multiple linear regression prediction outputs. Okay. First I select my price and pred multi, and then pass them to a scatter plot. Plot scatter, I hit tab and let's see if it will autocomplete. Yeah, it autocompletes. And on my, what did I say? I said on my x-axis I want my price, and on my y-axis I want my predictions. Let's first run this. See, in the this looks better because we have more dots closer to the diagonal line. In this simple linear regression scatter output, we had our dots more concentrated on this corner. And this one, because this is still a bad model, but you can see that it is slightly better, just like you have observed it in the R-squared and RMSE. Just looking at visually to the dots. Okay, this is another nice tool for your tool belt to check how predictions versus the real target variable look like. All right, yeah, we will continue in the next one. So see you there.
Hey everyone, thanks for watching. If you enjoyed this video, please let us know by liking and subscribing. If there's another topic that you'd like to learn more about, leave us a comment. We would love to hear from you. And if you want to become a coding pro, visit our website at codingnomads.co. See you next time.